All right, in this lesson, we're going to be looking at compound machines. And all a compound machine is just more than one simple machine used together. All right, don't forget when you're doing your calculations, you do get to use your reference page so you don't have to memorize the formulas. All right, so if we look at this first example, we actually have two simple machines. We've got the inclined plane, which I'll just call the ramp. And then we've got a wheel and axle. And even though this doesn't have a wheel circling around it, this handle just acts like the spoke of a wheel. So we're turning this handle with this axle. All right, so if we want to find the IMA, the ideal mechanical advantage, we just find it for the ramp and then find it for the wheel and axle. And then we multiply the two mechanical advantages together. So the ramp will be 15 divided by 5, which gives us 3. So it has a mechanical advantage of 3 to 1. The axle, we take the 3 divided by 1.5. That gives us 2. So it has a mechanical advantage of 2 to 1. Now to get the total ideal mechanical advantage, we multiply them together and we get a total mechanical advantage of 6 to 1. All right, now the actual mechanical advantage is just the resistance over effort. So we're moving 120 pounds. It's taking us 24 pounds of effort. 120 divided by 24 is 5. So that gives us an actual mechanical advantage of 5 to 1. Okay, the percent efficiency, that's just the actual mechanical advantage divided by the ideal mechanical advantage. Then we multiply it by 100 to change it to a percent. So that's 5 divided by 6, which gives us 0.83 repeating. We multiply that by 100, and we just round that off to 83.3%. All right, now in this one, we've got our wheel and axle back. We just changed the dimensions a little bit. But we also have this block and tackle system, which has 2 moving pulleys. Now we're getting the mechanical advantage of a pulley system. We look at the number of strands of rope or cord or strands coming off the pulleys that are moving. The stationary pulleys, these just change direction. Okay, these are attached to the ceiling up here. These do not move. These 2 pulleys move, and we've got 4 strands coming off of them. We don't count this one because this is coming off a stationary pulley. So we just count the strands that come off the moving pulleys. So our pulley ideal mechanical advantage would be 4 to 1. Then our wheel and axle, which this one's kind of a lever and axle. Just like the last one, it's 2.5 divided by 1, which gives me 2.5 to 1. To get the total, we multiply them together. 4 times 2.5 is 10. So the mechanical advantage of this system is 10 to 1. All right, the actual mechanical advantage is the same with any of the systems. It's the resistance divided by effort. So it's 225 divided by 26.5, which gives us 8.5 to 1, or 8.5 to 1. Now to get our percent efficiency, again, it's the actual mechanical advantage divided by the ideal mechanical advantage. Then we multiply it by 100 to change it to a percent. So 8.5 divided by 10 is 0.85. We multiply that times 100 and we get 85%. Right now in this one, we've got 3 systems going. We have this first class lever. Now it's actually going to have a mechanical advantage of a little less than 1 because the side we're putting our effort on is the shorter side. So to get a mechanical advantage of greater than 1, we'd need to put the effort on the longer side. So this is going to have a mechanical advantage of less than 1. We have a moving pulley with 2 strands, and then our wheel and axle again, or lever and axle. All right, so now this time we have 3 simple machines. We've got the pulley. It's going to be 2 to 1 because there's 2 strands coming off the pulley that moves. The axle, 2 divided by 1, which is going to give us 2. So our advantage there is 2 to 1. And then our lever, again, our effort is on the 4-foot side divided by the resistance on the 5-foot side, so we get 0.8 to 1, or we would actually call that 8 to 10. But when we multiply, we want to have the same units on each of them. Since the pulley and the axle are 2 to 1, then we'll need to use the 0.8 to 1. So we've got 2 times 0.8, which gives us 3.2 to 1. Then our actual mechanical advantage. This one we're going to take our resistance, which is 300 pounds, divided by 105. We get 2.9 to 1. So our percent efficiency. Our actual mechanical advantage is 2.9 divided by the ideal mechanical advantage, which is 3.2. And that's going to give us 85%. Okay, last one. All right. So on this one, we've got a few different ones. We've got a movable pulley, so we've got a pulley system here. We've got a wheel and axle. And we've got a lever. And we've got an inclined plane or ramp. So that actually gives us 4 simple machines. Okay, so the pulley is going to be 2 to 1. Our axle will be the 2.5 divided by the 1.5, which gives us 1.6 repeating. So I just round that off to 1.67. All right, same with the lever. Okay, our effort is on the 5-foot side divided by the resistance side, which is 3 foot. So that also gives us 1.6 repeating. So round off 1.67 to 1. Whoops. All right. Then the ramp is 12 divided by 8, which gives us 1.5 to 1. And then we multiply all 4 of those together. 2 times 1.67 times 1.67 times 1.5 gives us 8.37 to 1. Now the actual mechanical advantage is a little bit easier because again, it's just resistance over effort. So we've got 110 pounds divided by 25, which gives us 7.33 to 1. To get the percent efficiency, actual mechanical advantage is 7.33 divided by our ideal mechanical advantage of 8.37. And I just rounded off to the 10th place, so we get 87.6%. So with compound machines, we just calculate the mechanical advantage of each of the simple machines and we multiply them together.